Hey everyone, welcome back to my channel. Hope all are good. Today we are going to do a new experiment with ESP32, and this time we will connect our ESP32 with MQTT. Okay, and we will experiment publish data, and we will control the onboard LED of ESP32, and we check the reliability of ESP32. Okay. This is the problem with HTTP. Why we are not using web server in our IoT in devices. First problem is pooling. Let's say your ESP32 or your it will ask the server is there is any available data, so it will busy the server constantly. If there is thousands of devices, then thousands of devices are asking the server is there any data, so it will not good for embedded devices. So, and latency high over it, opening and closing the connection is takes some times. Battery powered devices, in our IoT devices there are maximum battery powered devices, so it will not good. The solution is MQTT. What is MQTT? MQTT is Message King Telemetry Transport Protocol. So what is the difference between the MQTT and HTTP? The push pull. Okay, and in HTTP always we need to ask the server is there any data, but in MQTT you don't need to do anything. Your MQTT server, whenever there is a new data, it will push the data to the specific devices. Okay, so data is sent only when something is sent, and it is instant, no handshake over it for every message. And ESP32 doesn't need to know who is the receiver is. Okay, it's just published the data with a specific topic, and there is devices who is subscribe on the topic, so he will get the data instantly. So it's like an WhatsApp group, everyone subscribe and gets it instantly. How it works? The publisher, the broker, and the subscriber, there are three major things. Okay, I made the animation for you, so it will help you to understand more visually. Okay, there is two ESP32 node like sensor publisher, and ESP32 connect with an LED. Okay, so our ESP32 node publisher sending every 5-second interval data in topic home temperature. Okay, our broker, this is a public broker, this broker receive the data and it sends the data who subscribe with home/temperature. Okay, home-temperature. So it will send the data there. You can see there is a web dashboard. It will update the data, the temperature data. Okay, very simple. So, and this is our another client. This is a mobile app. So if we turn on the LED, it will goes the command LED on, and it will then publish the data with LED on, whoever subscribe with home.live. So this is our publisher, and this time this ESP is subscribed with this topic. Our mobile client publish the data to this home-light. Okay, so it will send off command, then it will go to the broker, and then it will go to ESP32 second devices. Okay, and now the LED is off. Okay, this is very simple. I hope it will help you to visualize how MQTT works. We will publish the data from one of our ESP32. We will control the ESP32 onboard LED, and we will physically unplug the ESP32 to see if the broker detects the failure. So the setup, there is simple setup. We need a ESP32 and we need a LED. ESP32 have onboard LED, so you can use this LED too. Okay, and we need MQTTX desktop software to visualize the data. Okay, I will show everything, and there will be some library. Okay, this is the circuit diagram, and the diagram is very simple. Like our ESP32 have onboard GPIO pin, and the LED is connected to digital pin 2, and another leg with ground, and we need a resistor 330 ohm, so it will not burn. Okay, this is very simple. I hope you don't need a circuit diagram for this. So this is the code. I will put this code link in the description, so you can just download the code from here, and you need to change something, some parameter here. So this is SSID and password. You need to change this SSID with your home Wi-Fi and password. And we need to change the MQTT server. If you have any MQTT broker, then you can change this broker address with your. And if you don't have any broker right now, then you can use any free broker. I will put a free broker link in the description. But if you want to install your own broker, MQTT broker, then I have a separate video on this. I will put the link in the description, so you can follow the step to create your own broker. Okay, and this is device ID. We should assign a device ID of our unique device ID is devices, and this is our topic structure. This is the most important things, the topic. Okay, so topic structure is device type, device ID, function. Okay, so device type is ESP32, device ID is unit 1, and function is data for publishing the data, and command for receiving the command, and status, this is the last tool if our device is alive, online or offline. So we will publish our device status on this topic. Okay, very simple. And we need to create some objects here. Wi-Fi client, this is ESP32 client, and PubSubClient is ESP32 client. Okay, and this is for Wi-Fi enabled devices. And if you want to connect your ESP32 with MQTT via cellular network or 4G network, then you need to switch your ESP32 Wi-Fi with the cellular modem. Okay, I have a separate video. I will put this link in the description too. So if you want to connect with ESP32 with MQTT using GSM network, then it can follow. Okay, so we will send data on every 5 seconds, and we will control the LED, onboard LED. This is 2. Okay, this is the setup Wi-Fi. Very simple. You can connect with Wi-Fi and print the local IP. And this is the callback function, which is responsible for taking the command from the broker and execute. Okay, so our command is on and off. If on command is received, then we will trigger our LED to high and we'll publish the status. And if our message is off, then we'll turn off the LED and we'll publish the off status. Okay, simple. And this is the reconnect. It also important function, because sometimes our ESP32 disconnect from MQTT broker. We'll check after some interval, and if the client is disconnect from the MQTT broker, we'll reconnect. Okay, so when it is connected again, then we can subscribe. We'll publish the online that our device is online, I am online, and we subscribe the topic. Okay, command. And this is set up Wi-Fi, and you can see it's set server or the server MQ report and callback. This is the callback. Okay, we'll make sure. And this is the loop. If we'll check the reconnect here. If client is not connected, then we'll call the reconnect function. This is the important statement, client.loop. You need to always run this client.loop inside the loop, otherwise your ESP32 won't receive any message. Okay, and we will non-blocking timer for telemetry, and right now we use JSON to device ID, uptime, and Wi-Fi RSS. So this will print the Wi-Fi strength, and we will simulate our temperature. Okay, this is the temperature value random. We'll not connect any real sensor with the ESP, but you can connect very simple. Okay, I just show you how you can send the data. Okay, this is buffer, and we'll publishing the data to the buffer. Okay, let's connect this up to the code. So ESP32 module com is 8. Let's update. Okay, done uploading. Let's open the serial monitor and press reset. It is connecting to the Wi-Fi. Wi-Fi is connected. We got IP address, and attempting MQTT connection is connected, and it start publishing the data. Okay, now let's visualize the data. So open MQTTX. So MQTTX is a desktop client. I put the link description. You can download this and install it. Okay, it is free, so we can visualize our data. Okay, we need to add some info here, like ESP32 test. Okay, so this is our name, and the host name here is the IP address. Okay, this is the IP address. Port is 1883, port is 1883, and username and password. I don't set any username and password, so leave it as well. And we need to add the last will topic. Okay, this is the last will topic we need to add. So this is our last wheel topic is this one, last wheel topic. We copy this topic and open it. Okay, last wheel topic is this. Okay, so let's connect, and you can see it is connected. Okay, so we need to subscribe with the topic. Okay, so our ESP32 publishing data with this topic, so we need to subscribe with this topic. So this is our data and confirm, and I hope yes, it is starting receiving the data. You can see, okay, the data we are receiving, and how we can send the command. Okay, this is our command. So we need to send command from this. Okay, and select the plain text. Okay, and the last tool. Okay, this is the last tool topic we need to subscribe to see the device status. Okay, okay, you can see we print the last statement is online. Okay, we'll check to disconnect it physically, and let's open. Okay, now we will test the command. Okay, so let's send the on command. On command I sent on command. You can see our ESP32 received the on, and you can see in our ESP32 circuit the LED is on. Okay, and we will send off command. Okay, I sent off command, so it will publish the LEDs off, and you can see our LED is off. Okay, this is very simple and very easy. I think it will help you a lot. Okay, let's send another LED on, and on. LED is on and off and off. Okay, now we will test our last wheel function. Okay, so what I tell, if the device is disconnected from the Wi-Fi or power failure, then our server will notice us this device is offline. Okay, let's disconnect it physically. Okay, I just physically disconnect, and in the screen you will see, okay, you can see our topic status is offline. So our broker just sent the offline, this device is offline. Okay, if we say connect it again, okay, this is online, and start to sending the data. Okay, so that's it today. I hope this video will very helpful for you for your next project, and if you face any problem, please comment us. Okay, and if it really helps you, then please subscribe my channel. Thank you.